This video will try and explain peak splitting in Proton NMR. So peak splitting tells us about the number of protons on the adjacent carbon atom, and we'll be looking at the n+1 rule, so where n is the number of neighbours. This table summarises the number of adjacent protons. So let's start if we had 0 adjacent protons, so there would be no hydrogen atoms on the carbon next door. So take these 3 hydrogens, let's introduce an adjacent carbon atom. So how might that have no hydrogens on it? Well, if we made it a carbonyl group, and then as long as this isn't a proton, so it could be another carbon, as in a ketone, or perhaps an oxygen in an ester, so we can see that there are no protons on that adjacent carbon. So n is 0, so n+1 of course is 1, and the appearance of the signal is just one single peak, which is known as a singlet, and since there's just one single peak, then there is no peak height ratio, so we will just have one single peak appearing in the spectrum. So moving on to one adjacent proton. Again, I've put a methyl group down, and here's our adjacent carbon atom, and we want one proton on that adjacent carbon atom, so we could perhaps make that a chlorine. So the number of adjacent protons there was 1, so n+1 means that of course we've got 2, and this signal will appear as a doublet, which will look like that, and those twin peaks are in a 1:1 ratio. Let's now look at an example where the number of adjacent protons is 2. Again, we'll start with a methyl group, so to give them 2 adjacent hydrogens. So this is, you can imagine, is going to be fairly common now, so every time we have an ethyl group, so the number of neighbouring protons is 2, so our n+1 now comes to 3, and this signal is known as a triplet, so there will be 3 little peaks that make up the signal, and they are in a 1:2:1 ratio. And finally, the example where the number of adjacent protons is 3. Well, this time we'll just reverse what we were looking at before. So let's say we've got the CH2, so on the adjacent carbon we just need to put 3 hydrogens now. n+1 will now bring us to 4, and this signal will be known as a quartet, and it will be split into 4 peaks in a 1:3 3:1 ratio, and mathematicians might now recognise Pascal's triangle appearing